Hey everybody, this is Miss Darty, and today I want to talk about covalent bonding and Lewis structures. There will be several videos over Lewis structures, but today I want to do the first video. So, covalent bonding, electrons are shared in covalent bonding, and what we're going to do today is draw Lewis structures, and in Lewis structures, we show the bonding in a molecule. So literally what you're doing is drawing the bonding in the molecule. And in a Lewis structure, the sharing of electrons is shown by a line. So you should have this slide. I highly recommend printing out this slide. And this is the procedure of how to do a Lewis structure. I'm going to take you through, by way of example, a couple of things to know about Lewis structures is that hydrogen never goes in the middle, and hydrogen never gets dots. And what I mean by dots is that we draw the valence electrons of the outer atoms, and we draw dots to show the octets. And an important idea to know is the octet rule. The octet rule states that when atoms bonds, they need to have 8 valence electrons. And so we are going to show how the atoms obey the octet rule. But hydrogen has a duet. Hydrogen in its octet has only 2 valence electrons. So we only need to draw the bond for hydrogen. So let's do some examples. The first thing you need to know how to do is find the valence electrons, and that is as easy as using the periodic table. Now, your periodic table is separated by groups, and the way you get valence electrons, elements in the same group have the same number of valence electrons. So it's very easy to get the number of valence electrons. And it's very easy to know the pattern of valence electrons. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Boron's group has 3 valence electrons. Carbon group has 4 valence electrons. Nitrogen's group has 5 valence electrons. Oxygen's group has 6 valence electrons. Fluorine's group has 7 valence electrons. And the noble gases have 8 valence electrons. So it's just 1 through 8. You skip the middle, and you have the number of valence electrons. So the first example I want to do is CCl4. And the first 2 steps, I like to make a chart. And what you do is you list the element, the number of atoms, the valence electrons, and your total. So we have carbon and chlorine, and the number of atoms is given by the subscript like usual. So even if there's nothing written, it's just 1. So carbon has 1 atom, chlorine has 4 atoms, and again the valence electrons is given by the periodic table. If you look on the periodic table, carbon has 4 valence electrons, chlorine has 7, and then we're just going to multiply across, and 1 times 4 is 4, and 4 times 7 is 28, and we add down the total column, so we get 32 valence electrons. Now this is a running total. We are going to go back to this total. So the next step is to determine the central atom. The central atom is most often whatever you have 1 of. Also, it's the first element listed. Or if you have carbon, it's always carbon in the center. So we're going to have carbon. And we're going to surround that by 4 Cl atoms. And then we're going to show the bonding, and we're going to show the shared electrons by a line. So we're going to draw a line in between the carbon and the Cl molecules, the Cl atoms. And then each line represents 2 shared electrons. So we are going to go back to our total, and we're going to subtract the number of electrons involved in our bonds. And like I said, each line represents 2 electrons being shared. So in CCl4 we have 2, 4, 6, 8 electrons shared. So we subtract 8 and get 24. Now what we're going to do, the remaining electrons are going to be dots on the outer atoms, and the outer atoms are the things attached to the central atom. And we are going to fill the octets by drawing dots on the outer atoms. Now, the octet rule states that when atoms bond, they need to have 8 valence electrons. That's the goal of bonding, is that every atom gets 8 valence electrons. So with chlorine, we're going to draw 6 dots because the bond is already 2, and so we need 6 more electrons to complete the octet rule. So we'll draw our dots. We've got 1, 2, 1, 2, maybe. Three, 4, 5, 6 around that first Cl. 1, 2, 1, 2, 3, 4, 5, 6. I'm drawing lines, but you guys draw dots. 1, 2, 3, 4, 5, 6 around the bottom Cl, and then 1, 2, 3, 4, 5, 6 around the left Cl. So we've got each Cl has 6 dots plus the bond makes 8 valence electrons. Now you come over to your total and you subtract your number of dots that you drew, and we drew 24 total dots, so we hit 0 valence electrons. Now so this is done. Once you hit 0, you might be done. In the next video I'll show you an example of when you are not done. But when you hit 0, it's unless you have a double bond, you're done. And once you hit 0, I want you to get into the habit of inspecting your molecule, your Lewis structure that you drew. And I want you to see if everything, including the central atom, has 8 valence electrons, because we need to obey the octet rule. So we've got carbon in the center. It has 4 bonds, which make up 8 valence electrons. So carbon, we have 2 electrons involved in each bond, so 2, 4, 6, 8 electrons around carbon. So carbon obeys the octet rule. And then the Cl has 6 valence electrons plus the bond makes 8 valence electrons. So now I want to do CCl3, or sorry, CH3Cl. And this is no different. You do element, number of atoms. From now on, I'm going to do VE for valence electrons, and then total. So the element, we had 3 elements here. We have CH and Cl. We have 1 carbon, 3 hydrogens, and 1 Cl. Carbon, look on the periodic table, we have 4 valence electrons. Hydrogen has 1. Chlorine has 7. Multiply across. 1 times 4 is 4. 3 times 1 is 3. And 7 times 1 is 7. Add down, and we get 14. So now we draw the Lewis structure, and if you have carbon, carbon is always in the middle. And we're going to surround that. I'm drawing the bonds already. And we have 3 hydrogen atoms surrounding the carbon and 1 Cl atom. I already drew the bonds, so each bond is worth 2 valence electrons. So we subtract 8 valence electrons from our 14 and get 6. Now, those 6 are not evenly distributed around each outer atom. What you're going to do, hydrogen never gets dots. Never ever. Hydrogen never ever gets dots. So the 6 valence electrons go on the chlorine. Maybe. Sorry, I'm having trouble. So the 6 valence electrons go around the chlorine. Now you see if the octet rule is obeyed. Hydrogen is a duet, so hydrogen is okay with being bonded. And then the outer atom of Cl has 6 dots, and the bond makes 8 valence electrons, so chlorine obeys the octet rule. And then check your central atom. If anything is going to be less than 8 valence electrons, it's going to be your central atom. The central atom has 4 bonds, which make up 8 valence electrons, so this carbon atom is good. So next I want to do NCl3. This one is an example of the last step that we do in the Lewis structure. And it's an example where we're going to have dots left over. We're going to have valence electrons left over. And when we have valence electrons left over, you put dots on the central atom. So we're going to take a look at this. So start off the same. Element, number of atoms, valence electrons, and your total. You have N and Cl. You have 1 nitrogen atom, 3 Cl atoms. Nitrogen on the periodic table has 5 valence electrons. Chlorine has 7. So 1 times 5 is 5. 3 times 7 is 21. Add down, which you get 26. So we're going to have nitrogen in the center, because we only have 1 of them. And we are going to surround that with 3 Cl atoms. And I already drew the bonds. Each bond is worth 2 valence electrons. So we are going to subtract 6 electrons there, which gives us a total of 20 valence electrons left over. Then we do dots around the central atom, or around the outer atom, sorry. Make sure you're drawing dots and not lines. My tablet's not working for me, so I'm drawing lines, but you guys draw dots. So we've got 6 valence electrons around each Cl. We have used, that makes 18 valence electrons left over. So we have 2 valence electrons left. Those extra 2 go on the central atom. So we're going to put 2 dots on the nitrogen atom. And subtract our 2 and get 0. Now when you hit 0, look at your Lewis structure and see if each atom obeys the octet rule. We have nitrogen has 2, 4, 6 electrons as a bond, and the 2 dots make 8 valence electrons around the nitrogen, so nitrogen is good. And then the Cl's has 6 dots and the bond makes 8 valence electrons. So this molecule, drawing the Lewis structure of this molecule, we're done. Okay, so now I want to move on to 2 different ions. And the ions have either gained or lost electrons. Now, if you have a negative ion, the Lewis structure starts off the same. You're going to have your element, your number of atoms, your valence electrons, and your total. So we've got Cl and O. We have one one Cl atom and 3 oxygen atoms. Each Cl atom has 7 valence electrons, and again, that's from the periodic table. Oxygen has 6 valence electrons. So 1 times 7 is 7, 3 times 6 is 18. So that is 25. And then what we're going to do is account for this charge. This -1 charge means that we have gained 1 electron somewhere. So we are going to add 1 electron, and again, that's the charge. So we've got 26 valence electrons. So Cl, we only have 1 Cl, so we're going to have 1 Cl in the middle. I'm drawing my bonds. We have 3 bonds, which is a total of 6 valence electrons, so that we're going to subtract 6 from the total, and we're going to get 20. And so next, fill in the octets of the outer atoms. So 6 dots around each O. And we have used up 18 electrons around all of the O's, so we have 2 left over, and the leftover dots go on the central atom. And then with ions, we're going to show that the molecule has gained 1 electron somewhere. So we put that in brackets and put a -1 outside of the brackets. And that just shows that we have gained 1 electron somewhere. The last example that I want to do is a positive ion, a cation. And so, again, this doesn't change how we set up our Lewis structure. We have your element, number of atoms, valence electrons, and total. You have Xe and F. Xe has 1 atom, F has 5. And this is an example of an expanded octet. Xe is going to have more than 8 valence electrons around it, and it's fair game to have more than 8 valence electrons around it. What happens is that the atoms use the empty d orbitals that they have to extend their octet. So Xe, we have 8 valence electrons for xenon, and then fluorine has 7, so 1 times 8 is 8, 5 times 7 is 35, for a total of 43 electrons. And we're going to account for this positive 1 charge. That positive 1 charge means that we have lost an electron. So we are going to subtract 1 and get 42 electrons. So XeF5 we have Xe with 5 fluorine atoms, and here each bond is worth 2 valence electrons, so here we have 10 valence electrons. So we have 32 left over, 32 valence electrons left over. So we're going to put 6 dots around each fluorine atom. And again, make sure that you are drawing dots. I am drawing lines, that way you can see them, and my computer is not letting me do dots for some reason. Okay, so we've got 6 valence electrons around each fluorine atom. That gives us a total of 30 electrons that we've used. So we have 2 valence electrons left over. Now it's no different than the previous 2 examples, excuse me, where you have electrons left over, so you are going to put them on the Xe. So 2 valence electrons around the Xe. So that's my intro to Lewis structures, and your homework over your first homework over Lewis structures is only over Lewis structures with single bonds. We're going to do Lewis structures of double bonds in another video, and then in another homework assignment. So thank you very much for learning with me today. I enjoyed learning with you.